We're going to start working on the second section for unit on exponents, dealing with negative exponents if the exponent itself is a negative number. This has the potential to be a little tricky, so make sure you take it slow, you ask good questions, and then I can help you on anything you need help with. So if we go back to what we did yesterday, or whenever you watched the last video, negative 2 squared would be just negative 2 times negative 2, which would be a positive 4. But the problem we have now is, what if this negative goes up to the exponent as well? Well, what this actually means is that you have to turn this into a fraction, so it goes 1 over negative 2 times negative 2, which would then be 1 over 4. And so the big thing we have to remember is that negative exponents means fractions, and I'll show you why that takes place over here. If we have 2 cubed, that's equal to 8. 2 squared, we know, is equal to 4. And 2 to the first is equal to 2. We know those from our last section. But if we notice the pattern going from here is that we're dividing by 2 every time. So 2 to the first would be equal to 1, and we'll talk about that more later. But 2 to the negative first, 1 divided by 2 is just 1/2. And 2 to the negative second would be equal to 1/4. So as soon as we get past this point, negative exponents will always be fractions. And that will always be true. There's no time that you would have a negative exponent that wouldn't at least have a fraction somewhere in the problem. So if we start working on these examples, we have 2 to the negative 2. There's a couple ways you could write that. You could write that as 1 over 2 squared, or you could write that as 1 over 2 times 2. It means the same thing. But either way, the answer will be 1 over 4. 3 to the negative third power would be 1 over 3 cubed, or 1 over 3 times 3 times 3, which would be equal to 1 over 27. Now, if we have, this is a little hard to see, but it's 1 over 5 to the negative 2. And when you have a negative exponent in the bottom of a fraction, that would actually then revert back up. And that would happen because you're going 1 over 5 squared, which looks a little confusing to see, but the truth is, if you have, it's like doing a fraction twice, it would revert back to its original self. So you get 5 squared is equal to 25. But if we had just regular 5 to the negative 2, that would be 1 over 25. Okay? A negative exponent in the numerator would go to the denominator. A negative exponent in the denominator would go back. 6 to the negative third, that would end up being 1 over 216. And this is where it can get a little tricky. 1 to the negative 2 becomes 1, if we have the exponent up here, we're going to distribute it to both first. It becomes 1 to the negative 2 over 4 to the negative 2, which means that each of these wants to flip where they are. So this becomes 4 squared over 1 squared, which equals 16 over 1, or just 16. Whoops, 16. Okay, so make sure you take these nice and easy. But the main thing is that negative exponents mean fractions somehow, somewhere in the problem. So I want you to try these on your own and see how they go, and then I will go through them. 1 over 3 to the negative 3 would be 1 over 27. We've done that one already. 8 to the negative 2 would be 1 over 64. 9 to the negative 2 would be 1 over 81. Whoops. Come on. Now for this, we have to distribute that negative 3 in both terms. And since they both want to flip, we'll get 3 cubed over 1 cubed, which becomes 27 over 1, or 27. Back to normal, 5 to the negative third, that would be 1 over 125, because 5 cubed is 125. And finally, at the end, we have a negative exponent in the bottom that wants to revert back to the top. So we get 2 squared is equal to 4. Now, I said we talk about negative exponents, and that's where we're at right now. If we have the number 2 to the 0, that is not 0. Not 0. Okay? What happens is anything raised to the 0 power besides 0 is going to be 1. Anything raised to the 0 power will be that, except for 0 raised to the 0, which is impossible. So if you ever get that problem, that one can't be done. But the reason why that happens, let me see if I have a slide after this. I do not. So let me go back. Here, if we noticed that in our table we made right away, 2 raised to the 0 ends up being 1 because we're dividing by 2, and that would always end up being 1. And that will be that way for any number. So going back, anything raised to the 0 power will always be 1. Okay? If you have any questions, make sure you ask me. This can be a tricky section.